Okay, great. So last chapter we talked about consumer choice and finding the consumer optimum. Oh, by the way, just out of curiosity, did you guys work out the quiz that I put up on consumer choice?
Yeah.
Okay. Kimiko, didn't we work together on that one?
Yes, we did. We did all three. Like I didn't get the answers now.
Okay, yeah. Okay, very good.
Thank you.
So let's move on to the new chapter, elasticity. So actually in the book, elasticity is chapter 19. So I'm switching them around. I did first chapter 20, which is consumer choice, and then I'm going back to chapter 19, which is elasticity. So let's talk a little bit about elasticity. What is elasticity? Basically, as long as two variables are related, they have some sort of a relationship, either a direct relationship or an inverse relationship. If they have a relationship with each other, we can calculate the elasticity between those two variables. And what the elasticity tells us is how closely related are they, or how not so related they are. So are they closely related or are they not so closely related? And if they have no relationship, if there is no relationship between those two variables, then the elasticity is going to be equal to 0 because there's no relationship. Okay, so elasticity shows how closely two variables are related to each other. We gonna focus on one particular elasticity, and that is the price elasticity of demand. In other words, we know that the law of demand says something like this: if the price goes up, quantity demanded goes down, and if the price goes down, quantity demanded goes up. There's an inverse relationship between price and quantity demanded. That's what the law of demand tells us. But now with price elasticity of demand, I'm going to be able to say something like, if the price changes this much, this percentage, 1%, 5%, whatever, if the price changes this percentage, this much, how much will the quantity demanded change? So if the price, I know that if the price goes up, quantity demanded goes down. But now with elasticity, I'm going to be able to say, if the price goes up 1%, the quantity demanded will go down 5%, 1%, 0.1%. That matters. That we care about that. How much does a change in the price impact a change in the quantity demanded? So with elasticity, we're going to be able to pinpoint, well, if price changes this much, well, quantity demanded is going to change that much. With the law of demand, all I know is that if the price goes up, quantity goes down. If the price goes down, quantity demanded goes up. Now, I know that the book mentions a whole bunch of elasticities. So there's, for example, there's price elasticity of demand. And that's the one that we're going to focus on. And I'm going to mention, I'm not going to write it down, but I'm going to also mention some other types of elasticities that are in the book. Another elasticity that they talk about is price elasticity of supply. Okay, so because we know that there's a relationship between price and quantity supplied. Price goes up, quantity supplied goes up. Price goes down, quantity supply goes down. Right? So we know there's a relationship. So now, if you have price elasticity of supply, you can say if the price goes up 1%, quantity supplied will go up 10%, 1%, 0.1%. So we're going to be able to say exactly how much. Okay. There are two other elasticity. Another one is income elasticity of demand. Okay. We know that there's got to be a relationship between our income and how much we want to buy, quantity demanded of goods and services. And obviously that relationship is a positive relationship. The more money we have, the more we can purchase. The less money we have, the less we can purchase. With income elasticity of demand, we say, well, if income goes up this much, quantity demanded will go up so much. If income goes down this much, then quantity demanded will go down a certain amount. So it's going to be a little bit more precise. And the last one is the cross elasticity of demand. And the cross elasticity of demand looks at the relationship between two goods. And we know that the relationship between two goods can only be between substitutes or complements. If the two goods are neither substitutes nor complements, then there is no relationship and the elasticity is going to be zero. But if we take, let's say, Coke and Pepsi, two substitutes, well, if there's a change in the price of Pepsi, there's certainly going to be a change in the quantity demanded for Coke. So for example, if the price of Pepsi goes up 1%, then we expect that quantity demanded of Coke will go up, right? Because price of Pepsi goes up, people will switch from Pepsi to Coke and they're going to buy more Coke. So now with cross elasticity of demand, you're going to be able to say, well, if the price of Pepsi goes up 1%, quantity demanded of Coke will go up 5%, 1%, 0.1%, whatever the elasticity is, and so on. So if that's for substitutes, if they are complements, milk and cereal. If the price of milk goes up, then we would expect that the quantity demanded for cereal to go down. So if you have the cross elasticity of demand between milk and cereal, you'll be able to say, well, if the price of milk goes up 1%, quantity demanded for cereal is going to go down, 5%, 1%, 0.1%. So depending on the elasticity. Okay, so those are some of the elasticities. You can do an elasticity for any two variables that have a relationship. Okay, so first off, I'm going to cover the price elasticity of demand for a single good, and we're going to take a look at the demand curve for that good and calculate different price elasticities depending on where you are on that demand curve. So let's draw a demand curve, and then I'm going to show you the elasticities of demand on that particular demand. And by the way, the symbol and the formula for price elasticity of demand, the symbol is an epsilon. That's how the convention is for elasticity. So the price elasticity of demand is equal to the percentage change in quantity demanded given a percentage change in the price of the good. Okay. So if the price changes, how much does the quantity change? Well, on a demand curve, here's a demand curve. Let me draw it like, whoops. Let me draw it again. There's a reason why I want to draw it again. Here, that's a demand curve. Price, quantity. Each and every point on that demand curve will have a different elasticity. And the values for elasticity will vary from here, where it's going to have an elasticity at that point. It's going to have an elasticity equal to infinity. It's actually minus infinity. But since all the values for elasticity are negative, we're just going to ignore the negative sign and just make them positive because we like to work better with positive numbers. Okay, so every point on this demand curve is going to have a different elasticity, and they're going to vary from 0 at this point to infinity at that point. And we don't have to worry about this right now, not for this class. And smack in the middle on this demand curve, let's say here, the elasticity is equal to 1. Well, what that means is basically that on this portion of the demand curve, elasticity is going to have values greater than 1. And on this portion of the demand curve here, the elasticity is going to have values between 0 and 1. So less than 1, greater than 0. Okay. Well, what does it mean? Here is what it means. Remember, the formula is that elasticity is equal to percentage change in quantity given a percentage change in price. Well, if the elasticity is greater than 1, if elasticity is greater than 1, that means that whatever the percentage change in price here, the value for the percentage change in quantity is going to be more than the percentage change in price. In other words, this guy has to be greater than this value here. This value has to be greater than this, and then we're going to end up with a number that is greater than 1. If we are on this portion of the demand curve, the values will be less than 1. That means that given a percentage change in price, this number here will be less than the percentage change in price. So if the percentage change in price is 5, will be more than 5. If the percentage change in price is 1, this will be less than 1. If this is 10, this is less than 10. And then we're going to end up with a value that is less than 1. Well, what is the significance for us? Because so what does it mean? Why do we care? Well, here's the significance. Let's assume that elasticity is equal to 5. So we are at a point someplace here on this portion of the demand curve where the value for elasticity is greater than 1. So let's say elasticity is equal to 5. Did I press the record button or not?
You're recording.
Okay, good, thank you. Elasticity is equal to 5. Well, let's see the meaning of it. That means that if I change the percentage change in price, if I change the price, let's say I raise the price 1%. What is going to be the percentage change in quantity? So unmute yourself and tell me if elasticity is equal to 5 and this goes up 1%, if the value here is 1%, what is going to be the value here? How much divided by 1% equals 5? 5, exactly, 5%. So that means that the quantity demanded is going to go down 5%. Well, let's think about it. Let's think about it. From a revenue perspective, money coming in, which is price times quantity, that's the revenue. If I raise the price 1%, and as a result, my sales are going down 5%, what do you think? Would that be good or bad? In other words, should I do that, or probably I shouldn't do that? Anyone? You raise the price 1%, and as a result, your sales go down 5%.
You shouldn't do that.
You shouldn't do that, right? You shouldn't do that. Because you gain from the increase in price, but you lose a lot from the lost sales because of that. So when you are on this portion of the demand curve where the elasticity is greater than 1, if I increase the price, the loss from sales is going to be greater than the gain from the increase in price. Therefore, it's not a good idea to jack up the price. My total revenues will go up, will go down if I increase the price. But what if I do the opposite? What if I do the opposite? What if I decrease the price? Well, when price goes down, quantity demanded goes up. But now I know exactly how much quantity demanded will go up because I know the elasticity equals 5. So I know that quantity demanded will go up 5%. So yeah, I lose from the lowering of the price, but I gain a lot from the increase in sales. So my total revenues will actually go up. So when we are on this portion of the demand curve, we would want to decrease the price in order to increase total revenue. Okay? This is called the elastic portion of the demand curve. So when the demand curve is greater, when the values for elasticity on the demand curve are greater than 1, you're in the elastic portion of the demand curve. So I'm going to write here elastic. Now, let's take a look at when we are at the point on the demand curve where the value for elasticity is it's less than 1. Let's say it's 0.1. 0.1 is certainly between 0 and 1. Well, let's see what happens. If I increase the price 1%, I change the price, I jack it up 1%. Well, price goes up, quantity demanded goes down. But since the elasticity is equal to 0.1, I know exactly how much quantity demanded will go down. Will go down exactly 0.1%. Good idea or bad idea to jack up the price? Good idea. Good idea. Because I jack up the price 1% and I only lose 0.1% from my sales. So yeah, it's a good idea. Okay. Let's do the opposite. Let's say that I decide, I want to increase my sales. So to increase my sales, I'm going to lower the price. And I'm lowering the price 1%. Yeah, my sales will go up. But how much will they go up? They will go up only 0.1%. So I lose quite a bit more from the lowering of the price than I gain from the increase in sales. So it's a bad idea. Okay? Basically, when we are on this portion, this is called inelastic portion of the demand curve. And I'm going to write this down. Inelastic means people are insensitive to price changes. In other words, they don't really care much about the price. Elastic, they care about the price. Well, what are you going to do if people don't care about the price? You're going to jack up the price. If they care about the price, you want to lower the price. So I'm going to create here a table. So when we are on the elastic portion of the demand curve, if we increase the price, total revenues go down. If we decrease the price, total revenues are going up. When elasticity is between 0 and 1, we're on the inelastic portion of the demand curve. And now if I jack up the price goes up, total revenues are going up. Price goes down, total revenues are going down. So on a demand curve, on this portion of the demand curve, you want to lower the price. On this portion of the demand curve, you want to increase the price. If price goes up, total revenue go up. If price goes down, total revenue go up. Well, what's going to happen here when you are at this point on the demand curve, where this is called unit elastic? When the elasticity is exactly equal to 1, that is called unit elastic. Basically, the percentage change in price is 1, the percentage change in quantity is 1. If the percentage change in price is 5, the percentage change in quantity is also 5. And when it's unit elastic, total revenue is maximum. We maximize total revenue. Now, somebody may say, well, then we solve the big problems. Firms should always produce at this point on the demand curve at this price because they're going to be able to maximize total revenues. But there's a problem. The goal of the firm is not to maximize total revenue. The goal of the firm is to maximize profit. And since we haven't talked about costs, we cannot talk about profit because profit is revenues minus costs. So the goal of the firm is not to maximize revenue. So you're never going to see a firm producing at this point on the demand curve with this quantity and this price, because we have to bring the cost in. So elastic means people are sensitive to price changes. They care about prices. Inelastic means insensitive. Insensitive to price changes. So when people don't care, if people don't care about the price, then you jack up the price. If people care about the price, then you lower the price. All right, let's do some calculations. We're gonna have to, on the test, you're gonna have to calculate some elasticities. Now, we have a problem. This class does not require calculus, and the elasticity is calculated with calculus because it looks at small changes in prices and quantities. And when you have very small changes, then you have to use derivatives, because that's what derivatives do. They look at very small changes. Well, we don't use calculus in the class, so we're gonna have to use algebra. Well, if we want to use algebra, then we're gonna have to make those changes not around the point. We're gonna have to stretch those points and make them big. Okay, so what we're gonna do is instead of calculating the elasticity at a point, which we cannot do because we can't use calculus, we're gonna make the elasticity on segments. We're gonna calculate it on different segments of the demand curve. So instead of points, we're gonna stretch those points and make them bigger. And now we can calculate around segments. We're gonna calculate the elasticity, the price elasticity of demand on a given segment, given this change in price, let's say from P1 to P2, and at P1 quantity is Q1, and this is Q2. Now, remember, the formula for elasticity is percentage change in quantity given a percentage change in price. Now, we run into a little bit of more of a problem. If you calculate the elasticity going in one direction, you're going to get one value. Going in the opposite direction, you're going to get a different value. Okay? Because when I calculate the percentage change, let me give you an example. Let's say that you go to a store and you see a shirt that is marked down from $50 to $40. Well, what is the percentage change in price? If we were to look at what is the percentage change in price going from 50 to 40? Well, it's going to be $10 divided by 50, the original price, times 100. So it's going to be 20%, 10 divided by 50. So it's going to be 20%. But now let's say that you go into a store and you see that a shirt has been marked up from 40 to 50. Again, it goes from 40 to 50, the same change. It's $10. But the percentage change is not going to be the same as before when it was from 50 to 40. Going from 40 to 50, that is an increase of 25%. Because now our base is 40. So the change is 10, but it's divided by 40. So you see, depending on which way you're going, you're going to get different values. So we have a problem. So to do away with that problem, instead of saying that, well, we're starting from here and this is our starting point, or we're starting from there and that's our starting point, we're going to do the change divided by an average of the two values, the two extremes. So it would be 10 divided by the average of 50 and 45. And that way, it doesn't matter which way you're going, you're going to end up with 10 divided by 45 times 100. So the way we're going to calculate elasticity now is going to be equal to the change in Q divided by the average of the two Qs divided by the change in P divided by the average of the two P's. Okay. So this represents the percentage change in Q. This represents the percentage change in P. Can anybody tell me what am I missing? Because I'm saying that this is the percentage change in Q and this is the percentage change in P. Can anybody tell me what am I missing both in numerator and denominator? Because I'm missing something. Anyone? Not a rhetorical question. Okay, I'm missing times 100 times 100. But since you have both in numerator and denominator times 100, I'm just going to eliminate it and just leave it at this. Okay. So let's do a calculation. Let's calculate the price elasticity of demand on a particular segment. So let's say that P1 is equal to 10, P2 is equal to $14. And at $10, people want to buy 200 units, and at $14, people want to buy 160 units. So higher price, lower quantity demanded, lower price, higher quantity demanded. Let's calculate the price elasticity of demand on that segment using the average method. Well, it's going to be equal to this. The change in Q is equal to 40. The average of 160 and 200 is 180. The change in P is 4. And the average of 10 and 14 is 12. So we can rewrite this as 40 divided by 180 times 12 divided by 4. So 0 with 0 go away. 4 and 4 go away. It's 12. So it's equal 12 divided by 18. And if we divide by 6, it's 2/3 or 0.67. So then we would say the answer is the elasticity is equal to 0.67. Elastic or inelastic? That portion of the demand curve, inelastic. Should the firm raise the price or lower the price in order to increase total revenue? Inelastic, raise the price, total revenues will go up. So this is the type of a questions that you will see on a test. I'm going to give you two prices, two quantities, and you're going to calculate the elasticity of demand on that segment using the average method. Other type of questions that you will see on a test will be something like this. If the firm raises the price and total revenues are going down, are they on the elastic or inelastic portion of the demand curve? And so if they raise the price and total revenues are going down, then it's going to be on the elastic portion of the demand curve. Now, here is a little bit of an advice. I mean, I know that you guys are taking the test online, and that's different from in class. But in general, I don't like people memorizing, well, if the price goes up and total revenue is elastic or inelastic. It's very easy to make yourself, excuse me, a table and just think this way. The most logical one is this. If people don't care about prices, the firm should increase the total revenue. So if people don't care about prices, means that it's inelastic. The demand is inelastic. So all you have to remember is this. Inelastic means insensitive. So if they don't care about prices, you're going to jack up the price. So if price goes up, total revenue goes up. That's all you have to know. And this is rather logical that, well, if people don't care about prices, then I'm going to jack up the prices. Well, that's all you have to remember, because then you have, and if price goes down, total revenues are going down. And then you say, okay, so when it's elastic, I'm going to do exactly the opposite. Price goes up, total revenue go down, and price goes down, total revenues go up. So as long as you remember the first one, inelastic, jack up the price, total revenue go up, well, then all of them, you will know all of them. Okay. And if you are at the point on the demand curve where the elasticity is equal to 1, you don't want to change the price because you are at the point where total revenues are maximized. Again, that's not the goal of the firm. It's not to maximize total revenues, but to maximize profits. But for now, since we haven't talked about cost, we really are just looking at maximizing total revenues. Okay, now let's talk about, since we talked about elasticity on a demand curve for a single good, we can also talk about the elasticity of demand for different goods. So we're going to compare what is the elasticity of demand for one product versus another. Is the elasticity more elastic for a product or for one good and less elastic for another good? Here's how I want you to think about it. Elasticity means people care about prices. The more elastic, the more they care about prices. The less elastic, the less they can do anything about it. In other words, when it's inelastic, the more inelastic, if price changes, the quantity demanded is not going to change very much. With elastic means that if the price changes, quantity demanded is going to change a great deal. So here is where I would like you to unmute yourself, please, and tell me this. We're looking at price elasticity of demand for 2 different goods. One of them is Crest toothpaste, and the other one is toothpaste in general. Toothpaste in general. So the demand for Crest toothpaste and the demand for toothpaste as a product. Which one is going to be more elastic? Which one is going to be more inelastic?
Crest, elastic.
Exactly, exactly. Crest is going to be more elastic. Toothpaste, less elastic. How come? Well, let's say that Crest decides to jack up the price on their product. What do you think people will do immediately? Switch to a whole bunch of other toothpaste brands. Okay, so they're going to change to Colgate, they're going to Aquafresh, whatever, Sensodyne or what. So very sensitive about changes in the price of Crest toothpaste. If, on the other hand, the price of toothpaste in general goes up, what will people switch to? Well, there's not much. They're not going to brush their teeth with Tide or whatever, detergent or something. So what determines whether the elasticity for a good demand is elastic or inelastic, more elastic, less elastic? Well, the main determinant is the number of substitutes that a product has. The more substitutes, the more elastic. The fewer substitutes, the less elastic. You tell me, what do you think that the demand for gasoline would look like? Would it be an elastic demand curve or an inelastic demand curve?
Inelastic.
Inelastic, right? No substitutes, inelastic. They jack up the price. We're still going to have to go to work. We're still going to have to go to school. We're still going to have to do shopping and stuff like that. So is it going to be impacted a little bit? Yes, of course it's going to be impacted. We're going to drive a little bit less, but we still have to drive. So when there are no substitutes, inelastic. The more substitutes, the more elastic. So that's why you're going to see maybe on a test, you're going to see questions like this. Let's say, of those four goods, salt, pepper, Coca-Cola, and tickets to the Super Bowl. Which one is the most elastic between salt, pepper, Coke, and tickets to Super Bowl?
The Super Bowl tickets would be the most inelastic because there's no substitute for that.
Right, very good. So, okay. Also, what doesn't have really substitutes?
Water.
No, from my example, I had salt, pepper, Coke, and tickets to Super Bowl. No substitutes for those. I would say that salt doesn't have substitutes. Pepper doesn't have substitutes. So what has a lot of substitutes? Coke. So Coke would have the most elastic demand curve. What else determines the elasticity for a product? Is the amount of time that we allow to take place. In other words, let's think about a product that is rather inelastic, has a rather inelastic demand curve, such as gasoline. Well, let's say that the price of gas goes up. In the short run, there's really nothing that we can do. But if the price of gas goes from $4 to $10, and it stays at $10 time after time for a long period of time, what do you think is going to happen? Kimiko, what do you think is going to happen if the price of gas goes up and it stays up?
People start buying hybrid.
Exactly. People will start buying hybrids. People will start buying electric cars. People will find that it's not so bad taking the bus. People will find that, well, even though I hate the people in my car, I'm gonna carpool with them. So what are we gonna do? We're gonna find substitutes. So the more time we allow to take place, the more time we have to find substitutes. So in the short run, the demand is less elastic. In the long term, is going to become more elastic. So graphically, let me show you graphically what happens if the price of gasoline goes up. Here's what's going to happen, folks. Initially, the demand for gas is very inelastic. In other words, a change in price is not going to impact the sales very much. So if the price goes from $4 to $10, well, quantity demanded is going to go down, but it's not going to go down very much, just a little bit. But what's going to happen over time, the demand for gas is going to become more elastic and it's going to flatten out. Like this. Okay? And this change in price from $4 to $10 is going to result in a drop in the quantity demanded for gasoline that is quite a bit larger. How come? Because we found substitutes. So what determines the elasticity for a product? The number of substitutes, that's number one, and the amount of time that we allow for changes to take place. Okay. So make sure that you do the quiz, and you're going to have to calculate a whole bunch of elasticities using the average method. And make sure that you're able to do those calculations. Okay. Basically, as long as you plug in the right formula, the change in quantity divided by the average of the two quantities, divided by the change in price, divided by the average of the two prices, you're going to come up with the right answer. And by the way, I just want to say that if you come up with a negative value, don't worry about it. The answer is going to be the absolute value, so it's going to be positive. So, because elasticity is always, price elasticity of demand is always a negative value. It goes from 0 to minus infinity. However, we just ignore the negative sign. So if you come up and the answer is a 4, but you came up with -4, then mark up 4, okay? Because it's the absolute value. Okay, at this point, let me just, oh yeah, I want to say one more thing. Tomorrow, I'm going to lecture again. I'm going to have another lecture is on production costs. Now, production costs, that chapter is not going to be covered in test number 1. This is the last chapter that is going to be covered in test 1. Okay. However, tomorrow I'm going to go over production costs. Okay. On test 2, on the next test, after this test, you're not going to have any questions from that particular, the production costs chapter. But all the subsequent chapters that we're going to cover after production costs will have production costs built into them. So I want you to watch the lecture, read the chapter, and understand why the costs look the way they do. You're not going to have any questions on any tests from that particular chapter, but the chapter on perfect competition, monopoly, monopolistic competition, oligopoly, they will assume that you understand, you have been over that chapter, over the chapter of production costs. Okay, so yes, Andrea, let me see. What time is the lecture tomorrow? Microeconomics, same time. Same time. Again, I'm going to tape it, and then I'm going to have it available to you. Next Monday, I will have a review for test 1. Basically, what I'm going to do is I'm going to go over the questions on quizzes. I'm going to go over the, I'm also going to take the test. I'm going to take test 1, probably on Sunday. I'm going to go over it, and I'm going to take it myself, make sure that I don't have any mistakes on what's the right answer and so on. And at that time, I will remember and figure out, you know, what are some of the more difficult questions, and I'm going to give hints on the review for test 1. So I will have the review for test 1 on Monday at 1 o'clock. Of course, it's going to be taped and then linked in Canvas. Okay, at this point, I think I can stop the recording.